1. Yes. Okay, so quick reminder. It says here the blank and the blank of a polynomial determines the end behavior of the polynomial. So remember from yesterday, that's the degree. Well, that's not big enough. The degree and the leading coefficient. So basically if the function is positive or negative of the polynomial determines the end behavior. The solutions to the polynomial, go ahead and write in solutions, determine the zeros of the graph. And remember, these are all the same type of names. Solutions, zeros, x-intercepts, and even roots are all the same names. And it's really how many times the zero occurs that will help you sketch the graph. So let's go ahead and let's see if we can remember what we did yesterday to do this first example. Sketch the graph of the following. First thing we would want to answer is what is the zeros, or what are the solutions when you set this equal to 0?
1, 3, and 2.
Negative 2, 1, and negative 3, right? So I would go ahead and that's where I would start in plotting my pieces. Negative 2, 1, and negative 3. The next good thing to do would be to look at the end behavior of the graph, which we know is determined by the degree. This is often the tricky part that many people miss. If this is in factored form, when I'm looking at the actual degree of the polynomial, I have to think about it in terms of standard form, as if these were multiplied out. So what would be the actual degree of this polynomial? X to the third, right? So the degree would be 3. Because if we technically multiplied this out, that would look like a y equals x to the third. Now, if we have time at the end, I'm going to review how you would multiply this out because there's 3 binomials. But for right now, you have to recognize that x, x, and x creates that x to the third power. Okay, so now since I have this as a degree of 3, how will the graph behave at the end? Or what's the end behavior? Does it go down, up, or up, down? Down, up. So I know it's going to start down, it's going to go up. And remember, I consider thinking about y equals x to the third, just the basic graph, and that makes me think of just the down-up scenario. Okay, so then I would go to my graph. I would go downward to start with, upward. I know the end behavior. And let's see what you guys can remember from yesterday. How do we know the behavior of the graph at each 0 value? Yeah, you look at each piece, so each what we call in math the linear factors, and see if the multiplicity, so how many times it occurs, is odd or even. So x plus 2 occurs 1 time, x minus 1 occurs 1 time, and x plus 3 occurs 1 time. So we say that each of them have an odd multiplicity. Odd, odd, odd. And I know this is a review from yesterday, but we kind of threw a lot at you yesterday to investigate, so I thought it would be a good day to just kind of revisit what did we learn, how do we throw it all together. Okay, so since it's odd, we know that means that it's going to pass through. So I can, just as a quick note reminder, therefore it's going to pass through at each of those 0 values. So I'm not concerned with how high the graph goes, I just know it passes through, and I know that it passes through in that way. If you took out your graphing calculator, you could actually enter this in and see how closely you got to the shape of the graph. You'd find that shape. It might be a little higher or a little lower, but we want just the sketch of the shape for today's purposes. Okay, with your partner. Okay, guys, go ahead and check your answer. Check. You can check to see your 0 should have been negative 2, 1. The degree was 3. The end behavior was down, up. This was similar to the previous problem. What was the one difference? You had this even multiplicity. What does the even multiplicity do again? Or if you have an even factor, the graph bounces at that 0, right? Bounces at the 0, x equals negative 2, and you can see that occur right here. So you can see that kind of bounce. The graph started going towards the x-axis, but bounced off of it, does not pass through. Any questions on that? No? Okay, let's keep going. Oh, I don't know what happened there. There we go. All right. The next one, sketch the graph of the following. First of all, what would be the zeros of this graph? -2, 1, and -3. So that's where I'd start. -2, 1, -3. What's the degree of this polynomial? Yes, because it's x times an x squared, so that would create an x to the 4th. So the degree is 4. I have a negative leading coefficient. So what does that mean about the end behavior since it's an even degree with a negative leading coefficient? Down, down. So right away, I know that I can draw the ends of the graph as down, down. What's going to happen at the 0, x equals -2? It's going to go through, I know that. What's going to happen at the, so this multiplicity is odd, you could say. What's going to happen at the 0 value of x is equal to 1? It's going to go through because the multiplicity is odd. What's going to happen at -3? It's going to bounce. Excellent, because the multiplicity is even. So at -3, I know I'm going to bounce, but that's going to be the only place that I bounce at. So this graph bounces, goes through, and if I've done it correctly, I'll always match up with my end behavior of the graph. Okay, this last one, do on your own. Okay, guys, most of you, I saw good things. You should have had the graph bounce at the 0 value of 1, but go through the 0 value of 2 and -3, and the end behavior should have been both facing downward. Any questions on that so far? Jeremiah?
You go with like the
up, down, yeah, all that weird stuff. Okay, let's do kind of like just a quick reminder. Maybe I should have done this at the beginning. Remember, if you have y equals a positive x to the odd power, like y equals x cubed, it's going to match the behavior of y equals x cubed. Specifically, the graph is going to match, meaning it's going to go down and then up. Versus if you have an odd degree function with a negative leading coefficient, like y equals -x cubed, it's going to match, the ends of the graph will match the behavior of that graph. So if I think of y equals -x cubed, it would look like this. So it will match the behavior at the ends of the graph, meaning it will start up and go down. And then there's only two other scenarios, if it's an even degree or if it's a negative even degree. So if I think about y equals x squared, if I have any even degree function, it will match the ends of the behavior of this basic graph. So the ends of the graph will match the behavior where the ends of the graph will both be going upwards. Versus if I have a y equals -x squared, or if I had a -x to the 6th, or a -x to the 8th, or a -x to the 10th, it would match the behavior of this basic graph. So I know that it would go down and go down. So for example, if I look at this basic function above, if I multiplied all of this out, I would have something like y equals -x to the 7th and a bunch of stuff after it. So is this an odd degree or is this an even degree? Odd. And does it have a negative leading coefficient or positive? Negative. So it's going to match, or the ends of the graph is going to match the behavior of this situation. Does that help? Good. Okay, let's go ahead actually to kind of really drive this home. Do you guys remember, go back to the first example. Do you remember how to actually multiply all of this out to put it into standard form? You do one of them first, so you would like FOIL one of these first. So it would look like y is equal to x squared, let's see, plus 2x minus 1x would give me plus x minus 2. And then what do I do with that x plus 3? Distribute the x and distribute the 3, right? So if I think about what this function would look like in standard form, Just as a quick reminder, it's been a Christmas break since we did these types of problems. It would be x cubed, that's weird, x cubed plus x squared minus 2x, and then distribute the 3. So plus 3x squared plus 3x minus 6. So the actual function in standard form would look like x cubed plus x squared plus 3x squared would give me plus 4x squared. Minus 2x plus 3x would give me just x. And then I have the minus 6 at the end. Now, I don't care about the function in standard form. I mean, I might have to do it later in my future. It is an algebra skill that I should have mastered. But what's important to recognize is that this determines the degree of the function, which is what makes the end behavior. And that is an important piece to sketching a graph. All right, guys, so your homework, oh, let me turn this off.